Okay, example 2 here has us evaluate limits looking at this graph. So it's going to ask us a bunch of questions, and some of them are limits and some of them are just, hey, what is the function at this value? You need to be able to read this type of question. So the first question right here, A, says what is f of 2, which means what is y when x is 2, right? F of 2 means what is y when x is 2. So here's x is 2 right here. So, okay, we have an open dot right here, and we have a closed dot at the other side. So we have an open dot here and a closed dot here. Which one do I use if it asks for f of 2? Well, you use the one with the solid dot, because open means it's not really there. So I would say that y is equal to -1 when f is 2. So that would be -1. B asks us, what is f of -1? So what is y when x is -1? So now we're over looking at this group. And what is y at -1? Well, if I'm following the graph, it goes like this, and then it has an open hole and a solid dot up here, which is jump discontinuity, right? And then it continues on. But if we want to know what the function actually is, it's got to be where the dot is. It's got to be the y where the dot is. So this would be 4. All right, C asks us what 4 is the limit, not what 4 is. So it's not asking the function, it's saying what is the limit at 4 from the left. So we're looking at 4 here. Here's 4. Put a little dot there, circle 4. Coming from the left, what does it appear to be? Y appears to be 3. All right, D asks if you go to 2 from the right, what do you get? So here's 2, and if I'm coming at 2 from the right, what does the limit, not what is it at 2, which would be down here at -1, but what is the limit approaching as I'm like coming down here? It's approaching 1. Is this making sense? Okay, let's keep going. As the limit as x approaches 2 from the left. All right, here's 2, and if I'm the graph approaching 2 from the left, where am I? I'm at -1. All right, F, the limit as x approaches -4 from the right. Well, here's -4, and if I approach it from the right, from this side, it looks like y is going to be 2. All right, -1. The limit as x approaches -1 from the left. So -1 from the left would be this guy. And what does it appear to be? What is the y? It's equal to 2. All right, we're skipping now over to back to -4 from the right. Uh-oh, I think I did that. Sorry, I think I put the wrong thing here. Maybe didn't do this one right. Let's look at -1 from the left. Oh, it's right, but accidentally. -1 from the left is coming up this way, and it appears to be 2. So that one was right. I skipped down and was doing H instead of F before. Okay, I, the limit as x approaches -4 from the left. All right, now this is important, so listen up. Oops. I'm trying to go to -4 from the left, but there's nothing to the left of coming from the left to get to -4. Here's -4. So there can be no limit. There's nothing there. So what we write is DNE for does not exist. You don't have to write it out. I'm just writing it out so you know what it means. The limit does not exist. Okay? Following, I hope. let's go to x going to -1. All right, so x is approaching -1. So here I am on my graph, approaching -1 from the left. Now look, it doesn't say from the left to right, so it means it has to look at both ways. And the only way the limit exists is if they both equal the same thing. And they sure enough do. Coming from the left, it equals 2. And coming from the right, it equals 2. So we're still good with 2 there. Okay, a few more of these. K says, let's look at the limit as x approaches 2 just in general. All right, so if I approach it from the left, I get -1. If I approach it from the right, I get 1. Those are not the same. Okay, so it doesn't exist. And if you had to prove why, you would say the limit as x approaches 2 from the left is equal to -1, and the limit as x approaches 2 from the right, f of x, is equal to 1, and they're not equal, so you could put a not equal between them. So there's why doesn't exist. All right, let's look at the next one. These are good problems. The limit as x approaches 5, and it just means in general. Now, as we approach 5, it looks like it's going to -2, okay? But it has an arrow. And that means it would continue on, right? We don't know what would happen, but it's going to continue down. And so if I'm coming from this way, and wouldn't I get the exact same thing? So because it's an arrow and not a dot like this side, where it just kind of ends, the graph ends, we can say the limit exists and it would be 2. -2, right? It's down here, -2. All right, 2 more. The limit as x approaches 0 of f of x. All right, so here we go. We're looking at the graph as it approaches 0, and it's down here at -1. And if we look at from the right, it wants left and right because it just asks in general. Don't they both equal -1? So that equals -1, an easy one. And then if we look at f of x equals -1. All right, -1. So we're looking at -1. No, +1, sorry. Messed this up. +1 coming from here, it looks like it's 2, and coming from this side, it looks like it's, I'm sorry, not 2, -2. So both sides were the same, and it's -2. All right, so that's how you do evaluate graphs, limits from graphs. It's pretty easy. You just have to be careful not to make careless mistakes.